After separation of variables, the ordinary differential equation is converted into this form. Then we take integrals at both ends, thus we get the general solution hy equals gx plus c. However, problems raise up after a serious check. The original ODE implicitly determines a function y equals fx, and we can write it as the form as this. It reflects the methodology to solve the equation. If we admit dx equals delta x, thus the integral of dz equals g prime x dx can result in gx plus c, but the integral of h prime y dy cannot result in hy, because according to the definition of the differential, dy is the linear main body, which is fx delta x equals fx dx. Whereas we know dy equals fx delta x, but doesn't equal delta y, thus we get dz over delta y equals h prime y, doesn't equal dz over dy. Therefore, the integral of h prime y dy cannot result in hy. Someone may say that the indefinite integral is also the inverse process of the differential, so that the inverse processes of taking the derivative and taking the differential are the same indefinite integral, namely fx plus c. This is wrong. Though the result of the inverse process of taking the derivative and that of taking the differential are the same fx plus c, the specific integral of fx dx itself can only be the inverse process of one of these two operations. Because taking the derivative and taking the differential are not the same thing. If it was the inverse process of taking the differential, there should exist integral of fx dx equals the integral of dfx equals integral dy. Thus when we used the second substitute method for integrals, according to the fundamental definition of the differential, namely dy equals fx delta x, we had integral of dy equals integral of fx delta x, where delta x equals the sum of phi prime t delta t, and ot delta t multiplied by delta t. In this way, we could find that its linear main body, i.e. the differential, was dx equals phi prime t delta t. Therefore, we have the equation as this. Could be deduced, which is obviously wrong. Why can the theoretically chaotic principles result in right conclusions? This is because the form of dz equals h prime y dy is right in sense of Leibniz system, where the dy, dz, and the corresponding principles. The definition of the differential are different from those in the current calculus system. In the current system of principles of integrals represented by Cauchy's theory, the indefinite integral is the inverse process of taking the derivative. But when facing equations of derivatives, this kind of indefinite integrals is helpless. And we have to transform all derivatives into differentials, and take integrals at both ends in Leibniz's way. Isn't it absurd?